All right. So, first talk of the day, very exciting. Our first talk is by Dillon. Ian's a staff security engineer at the New York Times, where he finally landed in cloud security after having wandered in the desert for years as a software engineer, DBA, and cloud engineer before coming to his senses. In this presentation, Ian will explain the common causes of GCR misconfigurations and how other GCP service defaults can widen that exposure. The title of the talk is Call Me Phishmael, Hunting Sensitive Docker Images and Google Container Registry Leaks, which I'm hoping for many sea shanties and whale puns. I hear the best we're going to get might just be lots of cursing, so, sailor talk seems right. Please welcome Ian.
Thank you. Hey, does this sound good? Oh, God, that's my own voice. So quick background on this talk. Back in April of 2023, a user misconfigured a GCP project to publicly expose a number of Docker images in GCR. Our own tooling and observability caught it super fast. We were able to fix it, crisis averted. But during remediation, we kind of walked the user through, like, show me what you did, right? And then we went, oh, dear God, that was ridiculously easy. It's obvious why you got confused, and it's just like this lurking foot gun in GCR. And then we were like, well, we're not the only people that this happens to, right? Like, screwing up doesn't discriminate. So certainly, there's tens of thousands of projects. This misconfiguration has to be sitting out on a ton of projects, right? Could we find them? If we did find them, what would the images be? Looking at the images, would they be particularly interesting? Would they be particularly juicy? And you also have to consider that the images found through this mechanism, the users thought they would be private. So you're kind of like pawing through someone's sock drawer, right? This isn't the images they built for public consumption. This is the images they built for their own internal workloads. So when we talk about observations and best practices, what we're talking about is patterns that we caught in the wild that happened with enough frequency that they could become a bullet point, right? We saw this so often that I can just say, this is a habit a surprising number of people have, right? You might be doing it too. So yeah, my name is Ian Dillon, security engineer at the New York Times. If for some godforsaken reason you want to find me on the internet, I'm on Twitter and Blue Sky at Amen Breakpoint. I don't post. You can't DM on Blue Sky. So, it's just a profile that's empty. Here's the rough plan for the presentation. It's basically in 3 parts. The first part, we're going to talk about Google Container Registry. Like, why are we talking about GCP and not ECR or whatever the hell Azure has, right? We're talking specifically about Google Container Registry. We're going to talk about design language confusion in their console. And then we're going to talk about how other GCP services use GCR in ways that you maybe aren't fully expect or fully aware when you sign up for these services. We're going to talk about GCP's deprecation of GCR and some other recent changes around GCR. And then we're going to talk about common issues we saw and best practices. I should say, very early May, we submitted a Google VRP report on this. So it was an abuse report, not an exploit report, which Google kind of treats a little differently. Abuse reports go through like the trust and safety team and are treated as like lower bounties and stuff. It's just like a whole separate category. So our report got triaged as an abuse report and finally got finished in mid-July. So from like early May to mid-July, we had an open VRP report with Google about GCR exposure, how it's easy to find. There's some recon methodologies that help you find them, and some other stuff that you can get around quotas and stuff like that. So this could be Like, the leaks exist, and hunting them can be weaponized due to the way GCR is configured and the way GCR works. So the best way to kind of explain how the misconfiguration works is we're going to make a new GCP project for our new company that we're all in, because when it goes wrong, I want us all to feel it. And my mom gave me $20 in VC money. So when you make a new GCP project, there's two user-supplied pieces. There's the project name, which can be anything you want. It's a display name, right? It doesn't have to be globally unique. GCP project IDs, however, do need to be globally unique. They also have to be DNS safe, which means A to Z, 0 through 9, and a hyphen. When you start this, give me a new project console, you get like horse battery staple 1, 2, 3, 4, 5, right? We're not going to do that because I don't like the aesthetics of a bunch of numbers. I'll forget them. I don't know what entropy is, right? So we are whaleco.io. Welcome to the company. We've got a week's worth of runway. We're on the free tier, so we got 3 months of runway. So the first thing you do is you go to the enable APIs, you type in Docker. This is the first result. The second result is Google Artifact Registry, the thing that is replacing Google Container Registry. What's missing from this screen is that after you enable it, you get told it's deprecated. So GCR is deprecated as of May 2024. Deprecated. And we'll get to what deprecation means for GCR. So we've got an empty registry. The first thing we're going to do is make the community edition of our flagship product, whale-say. The CE is for community edition. It runs, you can push it. Line 14, we're pushing up to our repository, or our registry. Kind of pay attention to what the registry URL is, right? It's the region / your project ID / your image. This company needs money though, so we're going to make an enterprise edition. And our enterprise edition charges for SSO. So that's -ENT for enterprise. Same thing, it runs, you can push it. We're pushing it to the same registry, whaleco.io, on the US GCR registry host. And if we go look at the console, you get kind of what is expected, right? 2 private images. What good is a community edition that's private though, right? So, but before we do that, GCR is a Docker compliant registry API. It has to be, right? Because you can Docker push, you can Docker pull, which means you can just curl it. You can make an authenticated request to GCR. If you do that, here's what you get for Whaleco right now. Denied. Everything's private. Working as expected. But we need to make whale-say CE public. So we go back to the console. We do everything in the console, by the way, right? We're CLIzer for nerds. So we click whale-say CE. So far, so good. There's the image we pushed. Then we click settings. And you can see way down here, there's this public access, and it says private. We click it. We get a little list pop up. We click public. Bam! It's public. What was missing in that user flow?
Consequences?
No, the consequences are coming. What was missing was the confirmation. There was no informed confirmation about what exactly, A, do you want to do this? And B, is this what you want to do? Right? You should be able to tell the user what's going on there. So let's go back to our curl statement. Our exterior actor does curl again. Oh no! Our flagship enterprise project is now public. So the gotcha, this is the whole UI confusion in GCR. Anytime, no matter how far you've drilled down in your image tree or whatever, if you click settings, you're changing the visibility for the entire registry, not just that one image. And the thing is, if you go and read the docs, it tells you this. No one reads the docs, right? It's the last thing anyone's going to do. So this is the root of all these GCR leaks. The other problem with this is it can happen at any point in time. If some point in the past you made the registry public because you wanted to make it public, but then another team starts using your project and starts pushing images, those images are public as well. They might not realize it, right? There's nothing in Docker push that tells you that you're pushing to a public registry. Now, if you go and look at GCR, it doesn't lie to you, right? It tells you it's public. No big surprise there, but in reporting this to a couple companies, they said, oh, we never went and looked at the console. Like, why would we look at the console when we just push and it's there, right? There's nothing you need to do in the console to introduce a new image repository in your registry. So they just don't realize it. So we've gotten a lot of feedback from our WhaleSay company or customers, and it turns out that they don't like running 64 gigs of RAM machines for WhaleSay. So we're going to pivot, and we're going to become a SaaS company now. We're going to host WhaleSay for people. So we need to adopt some GCP services to host it for us, right? First thing we're going to adopt is Google App Engine. Does anyone use Google App Engine? It's actually got a ton of users. It's been around for like 15 years at this point. Still under active development. They're still releasing updated runtimes. So we got WhaleSay GAE line 1. We're just typing gcloud app deploy. These are all defaults, right? This is just the default configuration for the default service in Whaleco IO. It spins for a while. It does some crap. Line 25, I can curl my new service. It works. All good. The one thing to really recognize or realize in this directory, WhaleSay GAE, there is no Docker file, right? This is just a bunch of no Docker files. However, it turns out that Google App Engine isn't sexy, doesn't look good on LinkedIn. And if I need a job, once WhaleSay crashes and burns, I got to pick something else. So we're going to go to Google Cloud Functions. Same story, all defaults. This is Google Cloud Functions first gen. There's a second gen that behaves a little different, but second gen is still not the default. Hit all the defaults, deploy it, twiddle your thumbs. It works. You can curl it. So what do you think is actually happening in the background of these default deployments for App Engine and GCF? They both depend on GCR. And they both build Docker images. And they both happily push to public GCR registries. So it means those two deployments I made are immediately leaking through my public GCR registry. I look at the App Engine console, doesn't say anything. I look at the GCF console, doesn't say anything. The other cool part about App Engine and GCF images, you get a new one for every deployment. So your leak includes the entire change history of your App Engine deployments. Like, you can find App Engine deployments going back to like 2019, right? So that's like the GCR story. Super easy to blow your own foot off because the UI doesn't really explain what's happening. And then compounded, I guess you blow your other foot off when you choose GAE or GCF and you inadvertently leak images that you had every pretty good reason to think was private. So here's an interesting thing about the relationship between GCR and GCS. Google Cloud Storage, they're buckets, right? GCR in actuality is a bucket. My registry is us.artifacts.whaleco.appspot.com. That got made automatically for me when I enabled GCR and pushed to us.gcr.io. It tells me it's public. But as a user, what the hell is this bucket? Like, if you go to Stack Overflow and search for these kind of bucket names, you find all these questions about like, why is this bucket 50 gig? What is this? Why am I paying for it? Can I delete it? There's no clear indication that this bucket is associated with GCR, right? I didn't make it. Maybe it's supposed to be public? I don't know. Here's the other interesting thing about GCS. Say you were an awkward looking guy who is trying to find a bunch of open GCR registries, right? GCR has request quotas. You can make like 50,000 requests every 10 minutes or 1 million total requests a day. It's hard to do mass scans under that limit, right? GCS, however, has no such quota. You can beat the crap out of GCS. It's designed that way. The buckets that back GCR registries are deterministically named. So when you need to find an open GCR registry, what you can actually find is the public bucket that backs it. And then you know that the GCR registry is public. So those GCR abuse quotas don't come into play. You just get to abuse GCS. So that's the abuse mitigation sidestep. Just go abuse GCS. You're supposed to, right? So let's talk about container registry deprecation. In May 2023, the banner in GCR changed from please migrate to artifact registry to GCR is deprecated. You need to migrate because in May 2024, GCR is deprecated. But if you read closely, it says container registry will remain available in projects where either of the following actions occurred before May 15, 2024. You've enabled it and you've pushed an image. So what deprecation actually means is in May 2024, you may not start using GCR. If you have been using GCR, you may continue to do so. So this drop dead date is when there are no new GCR users after May 2024. So another interesting thing is, since our VRP report, there's been a few changes to GCR, right? First, the GCR console now looks like this for public images. You get the nice warning triangle, the same thing you do in your buckets. This change was made within the last 2 weeks. Those slides that you saw from the console, those are from July 17th. So I took this screenshot on Friday. So this change happened since July 17th. They also did a container registry change back in June. There used to be an endpoint in GCR that tipped whether or not a project existed, given just the project ID, which is pretty useful recon information if you're trying to save yourself a bunch of spam HTTP requests. And it would tell you if a project ID existed, whether or not it was using GCR. So you could use it for a whole bunch of different recons. So they changed that. That was June 29th. There was one big change, however. Remember where I was like, I go here, I click this, it says public, I click it, blah, 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 blah. All that's a lie now. Because this Friday, August 11th, you may no longer change a registry to public from the console. You have to do it from the CLI, which is amazing news. Like, that's all I really, that's all I wanted. What's kind of funny about this is, if you do want to make a registry public, you have to do it by the CLI. The command to do it is to change the access control on the bucket. So then it becomes very clear that GCR is in fact just a bucket, right? So this was a great change, but I'm glad I looked. Like, I went to go look at the change log to make sure my slides were still correct, and they did this on Friday. So, thank you, GCP.
They're listening.
Yeah, I'm glad like the report spurred some action. I made a change in the world. So that's kind of it for the GCP side. So for the images we found in the wild, we found images across huge swaths of industries, right? Crypto exchanges, logistics, companies that handle buttloads of money for their customers. They're not banks, but they do international transfers. Tons of little app startups, healthcare information, like, again, messing up doesn't discriminate, right? All these companies made this really simple mistake and it hurt, right? So what are kind of like the observations and patterns we saw about bad behaviors and then best practices you can adopt to mitigate this stuff? The worst thing we immediately, besides the information disclosure of, I got your source code, right? I stole a runtime artifact that, depending upon the language, might be compiled, might be stripped, or might just be a bunch of Python, right? Who knows? But I can read it. So the first, bad behavior is obviously static secrets. These tended to be API keys for external SaaS vendors. Think SendGrid, Twilio, Slack, service tokens for other companies' APIs. We also saw a lot of Stripe, right? If a company handled money and they weren't doing their own internal kind of banking stuff, we saw Stripe keys, lots of them. The other thing we saw, and I'm kind of considering separately, is static secrets with no environment segmentation. Meaning, I got an image from my company-dev, right? But inside of that image was secrets for dev test prod. So you got one image with secrets for every environment. So I stole from a lower environment and with one GET request escalated to prod, right? Spring Boot projects were notorious for this. If I saw a jar file that I was like, oh, there's 3 property files in here. And I was right like 80% of the time. And the reason I think is the framework provides that to you, the property files across multiple environments. It's just something that's kind of built in. The other thing is the build artifact is a jar. And I think there's an out of sight, out of mind kind of thing that if the properties files isn't just sitting on disk, you kind of forget exists. But a jar file is a zip file, right? You just unzip it. It's all in there. The other thing we saw was a ton of static Google service account keys, which gives you kind of 2 things. One, GCP provides runtime identity for just about every workload inside of GCP, right? You can just attach a service account to your service and it should just work. But if people are putting static credentials in it, it means they don't understand runtime identity. Like, it's confusing. Or they're trying to bridge or normalize the software development lifecycle and make their local runtime behave like their cloud runtime. And the simplest way to do that, just static service account credentials, right? Another really common pattern we saw was environment variables. Everyone knows like the 12-factor app manifesto. It's got this advice that's worn pretty thin at this point, where you inject secrets into the runtime inside of process environment variables. Maybe not great advice anymore, but what's left unsaid or unexplained in the 12-factor app manifesto is the point in time that you put those secrets in your environment is as late as possible. Your orchestration should do it. The thing that is launching your application should be managing those process environments. We saw a ton of Node apps with some variation of this code. And if you could just Google .env multiple environments, you'll see a ton of Medium articles where good advice goes to die kind of stuff, saying this, do this, right? And so you'd crack an image open, there'd be .env, .test, .env, .prod, .env.dev. But the node code would be saying process.env.mysecret. So they are doing this weird cargo culting thing of, I'm reading a secret out of the environmental variable, but the environmental variable got shimmed by reading a static secret off disk. So it's like doing the thing but missing the point. We saw this a lot. And just talking about environmental variables, right? In Google App Engine, your manifest, down here on line 13, your manifest can include an environmental variable, right? For a long time in GAE, this was the only way to do it. It was before Google Secret Manager. You'll find a lot of conversations where people are like, I can't put this crap into Git, right? You don't commit secrets. And so they had all this weird like string substitution patterns during CI to fix this file, right? So we've got a secret called mySecret. We type GAE deploy, it grinds, it deploys. Now remember, our registry is still leaking, right? So a well-intentioned security researcher grabs your image, cracks it open, and there's your app.yaml with your secret. No access to the runtime. The file got written into the image. It got baked, right? By default, by App Engine. Which leads to the absolute killer thing we saw. And we saw it a lot. And that is build context leaks. So this doc is from June of this year. It's from the fine folks at CISA and our mandatory friends at the National Security Agency. And it's defending CICD environments. What? There was like at least four different talks at this DEF CON talking about CI/CD, right? It's obviously super sensitive. It's a very dangerous point at the software development lifecycle and deployment. All the context in there is very sensitive. Any credentials in play are probably very privileged, right? So they call it out. They say ensure secrets are never left embedded in software where they can be reverse engineered out. It is so easy to do this. And to demonstrate, we're going to take the naive, let's Google our problem away approach, right? So we're going to make a whale-safe service. This is our Docker file, okay? Pretty base. In fact, this Docker file comes from npmjs.org. This is entitled Dockerizing a Node.js Web App. I guess that's as official as you get, right? And for our CI/CD system, we're going to use GitHub Actions. And we're going to Google GitHub Actions push GCR. This is kind of like an amalgamation of the first page of results, again, from all the worst advice on Medium that Google bubbled to the top. But this is kind of like a pretty standard build flow for a Docker image, right? Line 10, check it out. Line 11, authenticate to Google using our static credentials that I have in a secret. Set up gcloud, set up Docker auth, build it, push it. Pretty standard stuff, right? If you build containers, your pipelines look pretty much like this. So we run this, I push to GitHub, GitHub Actions runs, it pushes, okay? If our well-meaning security researcher curls the tags for that image, we can see that it got pushed. So let's pull it down and crack it open. Line 13. Those are our GitHub credentials. No matter how good the hygiene was for that application, no matter how right-sized that service account was, what you just baked in was your CI/CD credentials. Your static CI/CD credentials, right? Look at all the other crap that got baked in. .git, if it doesn't contain your full history, at least it tells me where your Git server is, right? I can start doing attribution of this image back to a server or back to a GitHub org or back to a GitHub enterprise that you are running yourself or GitLab or blah, 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 blah. Git config can also contain the credentials that checked out the repo, which means I can pivot from an image into your Git, right? So I can get full history of all the projects that this key had access to. README files, util scripts, Terraform files, like With one pull, if you don't pivot immediately to static credentials, you get an insane amount of recon information, right? All from a single copy dot, right? The other interesting thing about this is that Docker images are an amazingly good forensic platform. I am doing this all on my local laptop, right? I can install any tool I want. If I screw it up somehow, I type rm dash, oh crap, I just exit and start it over. Like, I have an immutable image. I can just always start over. Also, I pulled this image. There's probably not an audit trail of that occurring, right? By default, GCR, that bucket that backs GCR has no auditing configured. So this is, I get to take something, there's no audit log, and then I get to paw through it to my heart's content, right? Think about having the complete Git history of any project that, again, that the developer thought was going to be private. All those commits that are said, lol, whoops, I can rewind time and find those keys that you accidentally committed and then didn't rotate because who the hell's going to see this? Whatever. Happened a lot. So, and this, what's the really striking and bad behavior here is static credentials for CI/CD systems. Just shouldn't be doing it. Full stop. And they call it out. In cloud environments, take advantage of cloud-provided temporary and ephemeral credentials that are available to compute services. Google has, what's it called? Google Workload Identity Federation, which means you can exchange an external token for short-lived SA credentials. And that token can be an AWS SIG, it can be an OIDC token. Go read the docs, it can support a ton of stuff, but it requires a ton of pre-configuration. And it requires a bunch of pre-configuration that you can also screw up, which people do a lot when they have to validate OIDC claims. Because you got to know how OIDC works, right? How do JWT signatures work? So it's no real surprise. People are like, screw this. I can just export a service account JSON file and it'll work. So, kind of like final takeaways, right? When you go back and you get back to work on Tuesday when you feel better, what can you do? Like, what can you trawl around in your org and see bad and be able to be like, oh, this smells, right? Number one, copy dot. Don't be doing it. It's really bad because it means you're not aware, or you have to constantly be aware of what is in build context, which can be surprising when you're running CI and it's just over there, right? You can't run LS in the middle of your pipeline and see what's in the working directory. And what's especially like nefarious about the build context leaks in this is you've baked the whole build context into your image, but your image works. So why would you ever look? The only time anyone pulls an image locally and cracks it open is when the thing is broken, right? I should say that whale-safe service that leaked the credential, it works just fine. Like, there would be no reason for me to pull it and look inside of it, right? It worked. Adopt Docker ignore, right? Docker ignore is a little iffy because it's an explicit block list. So you have to know the sensitive things that are in context to block them, right? Block lists are a lot harder to maintain than allow lists because you can always sneak past block lists. Line 5, maybe consider Docker multi-stage builds. You'll end up with smaller images. You have to be much more explicit about the things that you're copying into the final build. This is really dependent on your technology. Like, this works better for some technologies than others. And it's also a practice that's kind of driven by the community, right? Every Go example does this. Not many Node examples do it, right? So if I grabbed first of all, I can spot a Go image by the size of the image and know that if I grabbed it, it probably doesn't even have a shell in the image, right? What a pain in the ass for forensics. move on, right? There's lower hanging fruit for sure. 7, workload identity federation for CI/CD. Stop using static credentials. But we need, no. Stop using static credentials. If you are supporting developers who are using your pipeline, set it up for them. Because while you may control the build context and the infrastructure around your CI/CD system, you probably don't control the Docker file, right? So like the garbage in is the stuff you don't get to control, but maybe you can help filter the garbage out. Finally, reconsider how sensitive you treat internal Docker images, right? It turns out that they're really easy to screw up. And even if you're on your best behavior, you can still screw it up. So think about if you do internal segmentation by teams, who can pull what from where? What workload deployments can pull from what registries? Should they be able to do that, right? Because then you're talking about mitigation of pivots due to compromise, which is what you should be thinking about at every step, right? Something's always going to go wrong, but you need it to go wrong in a series for it to pay off. It shouldn't be like it goes wrong once and you're screwed. So just think about internal segmentation. And images are opaque, right? You just get this big fat blob. When you get back, download a bunch from your org, crack them open and look. Just go look. You'll be either like, great work everybody, these are spotless, or holy crap, like this is the worst possible thing. And then, paste it into Slack, like what the hell are we doing? But think about it, right? Just go look. If you're kind of interested in reading more about this, there is a paper in July, Secrets Revealed in Container Images, an internet-wide study on occurrence and impact. Same kind of deal. These researchers go trawl through Docker Hub, public repositories, and also do a bunch of port scanning to find default Docker registries on like port 5000 or something like that on the internet, and just pull from there. And they are able to correlate a ton of private keys in Docker images to public TLS certs, right? So they find all kinds of secrets, but those are the ones they actually validate using public data. So super cool paper. That's it. I think I hit time pretty well. So we have like 5 minutes for questions, or we can chat in the hall, or whatever works.
What do you think about the application at startup just using its cloud identity itself in an SDK to authenticate and get any secrets that it needs just in memory?
Right, so the question was, what do I think about using the process runtime identity to pull secrets from an external source? Yeah, that's what you should be doing, absolutely. You should be using runtime identity attestation to pull secrets at startup. Everything, use Vault, use Google Secret Manager, use AWS, use, if you're using Kubernetes, use volume mounts. Don't use secret ref in environments.
FS.
Use tempfs, yeah, like, just don't put it on permanent disk. Don't write it to disk, right? Just, yes, use an external secret manager where you use your runtime identity to pull the secrets. It also means that you can use your runtime identity to be much more strict about what secrets are available to what runtimes. Yeah?
Did you find a lot of, within layers, people removing their secrets, where you go back?
Found one today.
Okay.
Okay, so the question was, did you find secrets in layers that then got removed? Yes, which is like the most CTF-y thing in the world, right? There's a secret in a layer and you have to unpack the layers. Yeah, just today I found something that has to pull, it uses a build key to clone another repo, right? And so run, copy the build key in, clone it, remove the build key. That build key is still in the image, right? Unless you do it in one shot, it's in each layer.
One more.
You talked a lot about the footguns and the fact that sort of documentation and UI doesn't really address them. What sort of do you think is the best way for like better documentation and prevention of like footprints, especially when like describe like bad behavior?
So the question is like, what should we do about bad UI design and associating the documentation with it? Like, how do you get that information in front of users? I actually think AWS has the best pattern for that. Anytime you're about to do something dangerous or destructive, they repeat to you what it is you're about to do and what you're about to do it to, and then you have to confirm it by like typing delete or pasting the resource name. Right? That's just harm reduction. You're about to do something dangerous. Are you sure you want to do that? Cool.
Keep going.
Thank you.